So all year we've been looking at things in 2 dimensions, and now finally we're going to look at figures in 3 dimensions in chapter 10 here. So again, section 10.1 here is just going to be called solid geometry, but let's look at a couple warm-up problems here and sort of get a glimpse into what we're going to be doing here today. So it says classify each polygon. So number 1 says we have a polygon with 3 congruent sides. Okay. Remember, this is where just if sides are congruent, right? That's basically going to mean the sides are going to have exactly the same measure. Okay. Well, I'm gonna cheat here really quick, I think, and I'm just going to draw a triangle here. Oops. I'm going to go ahead and just draw a triangle, and if this is a triangle, it has 3 congruent sides, just like this. I think we call that an equilateral triangle, right? If they have all 3 congruent sides, and we know that if a triangle is equilateral, it's also equiangular. So this is actually what our figure looks like. So I would say for this first one, we will just call this an equilateral triangle. Okay. I guess it could also be, an isosceles triangle, but I think that's a pretty good definition there. And again, obviously, we know it's also equiangular. All right, now and the next one is a polygon with 6 congruent sides and 6 congruent angles. Okay, well, that's going to look something like this. Okay, so I'm going to have 1, 2, 3, 4, 5, 6. Okay, obviously my picture is not perfect here, but let's just assume that all these sides have exactly the same measure. Okay, and I guess we could assume that all of these have the same measure as well. Okay, all the interior angles here. Okay, well, this is actually just going to be a regular hexagon. Okay, so again, this is a regular hexagon. Again, 6 sides is what the hex means there. So this is a regular hexagon, right? 6 congruent sides and 6 congruent angles. Okay, and then finally, the last one that we're going to look at, this is a polygon with 4 sides and with opposite sides parallel and congruent. Okay, so let's go ahead and maybe draw something like this. Okay, opposite sides are parallel and congruent. Maybe something like this. Okay, so opposite sides for parallel would mean, well, the opposite sides are, this is going to be our marking for parallel. Okay, and if the sides are also congruent, we could maybe do a marking like this. Okay, well, this just actually meets all the criteria for a parallelogram, right? It has 2 pairs of opposite sides that are congruent and 2 pairs of opposite sides that are parallel, right? So this is just going to be a parallelogram. I got to be able to spell though. Parallelogram. Okay, so obviously when we look at things, different figures in 3 dimensions today, we're going to be doing some classifying. Okay, so that's why they're just seeing if we can classify some 2-dimensional figures as well. Okay, so let's take a look at our objectives for today. So again, just as I previously stated, we will be classifying 3-dimensional figures according to their specific properties, and we're also going to be using something called nets and cross sections to analyze these 3-dimensional figures. Okay, and here's just a quick look at lots of vocabulary that we're going to be looking at today. So we're going to look at a face, edge, vertex, prism, cylinder, pyramid, cone, cube, net, and cross section. Okay, so again, make sure that you're writing these definitions down, or at least putting a star next to them in the notes, and that you study them so that when you come across the particular word, you know what we're talking about. Okay, so let's take a quick look at this right away. So we basically these 3-dimensional figures, or you'll also hear us call them solids. Okay, they can be made up of flat or curved surfaces. Okay, so we'll be talking about a couple different ones today that have, again, flat or curved surfaces. Okay, so each flat surface is called a face. Okay, so again, the flat surface you can see that's shaded in kind of like a reddish purple here, that would be a face. Okay, so the edge is actually going to be a segment that is the intersection of 2 faces. Okay, so for the edge here, I want to point out a whole bunch of edges, right? So this would be an edge. Here's a second edge, 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 edge. All of these things I'm outlining in green here are all considered edges. Okay, so again, it's just a segment that is the intersection of two different faces. So all of these things that I'm outlining here are considered edges. Okay, and finally, the vertex is going to be the point that is the intersection of of three or more faces. Okay, and so again, we can see that if we have all of these faces right here, we could maybe outline a couple different faces in maybe like yellow. Okay, so if this is one of our faces here, okay, this would be another one of our faces right here. Okay, and here's one more face. Okay, so all three of those faces intersect at this point, which we just call a vertex. All right, so again, hopefully using the colors and stuff is helpful for you guys, but we have to be comfortable with this vocabulary so far.